We going?
Yes, sir.
You already hit the button?
Yes, sir.
Oh, hey there, Algebra 2. Good to see you. It is like almost 11 o'clock at night, and I'm still sitting here doing Algebra 2, and it's just kind of causing me to kind of lose my mind a little bit. That was kind of weird. Sorry. I'm sorry, that was weird. Man, why do I always do that? I always make things weird. Okay, let's start over. Hey, Algebra 2. Good to see you. All right, let's do it. Here we go. All right, so we are on, hang on, keep rolling. We are on the lesson entitled Mixed Expressions and Complex Fractions. And I'm only going to do some examples from the first section that's up through question 11. That's all I'm going to require of you to do for Wednesday. Okay. So we're going to go over a few examples. All right. Then we'll do the next section. I'll assign it to you on Wednesday, I guess. All right. So right up here. Ellie, you got this whole problem in view here?
Yes, sir.
So we got x plus 1 over x. Okay, so remember, we can put this x right here over 1, and we need a common denominator to add fractions, right? So if we want to rewrite this, that's x over 1 plus 1 over x. Okay, all right. We need a common denominator. So what is our common denominator going to be? Is there anything I can take x by, x times something to give me 1? No, there's not. Is there anything I can take 1 times to give me x? Yes, I can take 1 times x to give me x. So my common denominator is going to be x. So I'm going to rewrite this. So it's x over 1 times, okay, look, check it out, x over x, because I need to take 1 times x to give me that common denominator. And if I multiply the bottom by x, I have to multiply the top by x, because whatever I'm multiplying by has to be an expression of 1. And anything over itself is 1, right? Okay, so that's going to give me x times x is x squared. 1 times x is x. Okay, so now this fraction right here just became this right here. They're actually equivalent fractions. Okay, so I'm gonna rewrite this. So now it's x squared over x plus 1 over x. Okay, now we can add. So what's it going to give me? Well, I have a common denominator of x. Okay, x squared plus 1 is just x squared plus 1. I cannot combine those. Okay, now check it out. I can't do any kind of cancellation. So this is as far as I can go. Right there, here's my answer. Okay, so let's look at this one. Same concept. Okay, so we've got x minus x squared over x plus y. Okay, what should we do? First step. Exactly. Yep. Good answer, Darren. So we're going to take x, this x right here, and we're going to put it over 1. So x over 1 minus x squared over x plus y. I know I just used my finger. I'm sorry. Oops, I did it again. All right. So here's our new situation. Now, what do you think our common denominator is going to be? Exactly, it's going to be x plus y. So I need to take this fraction and make it into an equivalent fraction that has x plus y as a denominator, right? How am I going to do that? Well, x over 1 times x plus y over, x plus y over x plus y, right? Remember, whatever I multiply the bottom by, I have to multiply the top by. What does that give me? Well, it gives me, in the denominator, it gives me my desired denominator, which is x plus y. And then I'm going to take, so x times x is x squared, and then x times y is positive xy. Okay, so this fraction just became that. And we are subtracting, okay? We're subtracting, So remember what we talked about with the subtraction? Remember that? Do you remember what we talked about? When we're subtracting, what does this, so we can actually take everything and put it over that common denominator, right? So it's gonna, this makes this a negative x squared over our common denominator there. So we have an x squared and a negative x squared that cancel. So we're left with this. Xy over x plus y. Okay, we can't do any cancellation because we still have this addition sign right here. Okay, all right. Now let's jump over here. Ellie, can you bring the phone over here, please? Let's work on this problem right here. Do you have this whole problem viewer here? Mm-hmm. Okay, I need this entire thing, right? Okay. Hey, watch this. Woo! Okay. Just random. Wake up. All right. So we've got 2 minus x squared plus 10xy plus 7y squared over x squared plus 4xy plus 4y squared. Okay, exactly. Yes. Thank you, Ace. We're going to put that 2 over 1. Yes, exactly. All right. So I'm going to rewrite this. 2 over 1 minus x squared plus 10xy plus 7y squared all over x squared plus 4xy plus 4y squared. Okay, now we need a common denominator if we're going to add these two fractions. Now, what's our common denominator going to be? You guessed it. It's going to be this entire thing right here. Okay, because I can't take this trinomial and multiply it by anything to give me 1. But I can take that 1 and multiply it by all of this to give me that. Right? Does that make sense? Okay, so we need to change this fraction into an equivalent fraction that has that as a denominator. Well, let's go ahead and do that. Well, you follow me here? So 2 over 1 times, okay, remember, x squared plus 4xy plus 4y squared, x squared plus 4xy plus 4y squared. Okay? Now, what does that give me when I do that? That gives me, in my denominator, exactly what I needed, right? So x squared plus 4xy plus 4y squared. Okay, now, we're going to take 2, so this is going to be, I'm going to do my math right here, okay? So 2 times x squared plus 4xy plus 4y squared. Okay, so it's going to give me 2x squared plus 8xy plus 8y squared. Okay, all right, so check it out. This 2 over 1 just became an equivalent fraction. That is 2x squared plus 8xy plus 8y squared over x squared plus 4xy plus 4y squared. So now I have a common denominator that I can now use to subtract this fraction. Okay, now, so I'm going to rewrite everything, okay? We're going to come back down here. So I'm going to rewrite, I'm just going to bring this down, so that's 2x squared plus 8xy plus 8y squared. Now, remember, now we have our common denominator, so we can take everything in this numerator and everything in this numerator and put it all over that common denominator. So that's x squared plus 4xy plus 4y squared. Now, be careful. Remember, this subtraction sign causes everything in this other numerator right here to change. So it's going to be negative x squared, negative 10xy, and negative 7y squared. All right, now, last step that we need to do is we need to combine our like terms in the numerator, right? So let's see, where are all of my x squared terms? I've got an x squared term right here. I have a positive 2x squared, and I have a negative x squared. Okay, so that's going to become 2x squared minus 1x squared is just x squared. So I know it's going to be x squared, so I don't have to worry about these anymore. Okay, now I've got anything with an xy. Okay, so I've got an 8xy and a negative 10xy is going to give me negative 2xy. So I'm not going to worry about those anymore. And then I have an 8y squared and a negative 7y squared. It leaves me with a positive y squared. And those don't need to be dealt with anymore. And that is all over x squared plus 4xy plus 4y squared. And that is my answer. Oh, that is my answer to the problem that I just did on the board. I hope you're not bored. In an effort to keep you from being bored, I'm making up this ridiculous song. I can sing it all day long, but that would be oh so wrong for my mental state. Okay, that was, sorry, I apologize for that. All right, last problem. Man, this eraser stinks. All right, last one. Here we go. Right here. Right in the middle. A plus B, or sorry, A over B plus 1A quantity times, okay, A minus A cubed over A squared plus B. Okay. Don't be intimidated, right? All you need to do, first of all, simplify within the parentheses. So let's start with this one right here. Let's just pretend that this is just all by itself over here. Okay, let's not even worry about this yet. So if I was going to take A over B plus 1 over A, how would I do this? Well, I need a common denominator, right? What would my common denominator be in this case? Yes, it would be AB, or A times B. Okay, so I'm going to take A over B, my first term here. What would I need to multiply A over B by to get that denominator? Exactly, I have to multiply by A over A, right? A over A. B times A gives me AB. A times A gives me A squared. Okay? All right, so this fraction, A over B, just became A squared over AB. Now, let's go to this fraction here. What would I need to take? 1 over A times what gives me a denominator with AB? Exactly right. B over B. Right? So it gives me B over AB. So plus B over AB. And what does that give me, folks? It gives me A squared plus B over AB. Okay, so check it out. We come back over here. The answer is that right there. So we just simplify within the parentheses. So it gives me, I'm going to write this down so you don't forget, A squared plus B over AB. Okay, so I'm going to erase all this and I'm going to rewrite this down here. So A squared plus B over AB. Is that, okay? Now we're going to end up multiplying this times whatever we get when we simplify this one right here. Okay, so let's deal with this over here. Okay, Ellie, you got this in the view over here? All right, so A over 1 minus A cubed over A squared plus B. Now, what do we need to do if we're going to add these together here? That's right, we have to have a common denominator, which is going to be A squared plus B, right? So I need to take A over 1 and turn it into a fraction that has A squared plus B as a denominator, right? So how do I do that? Take A over 1 times, okay, so let's do it this way. A over 1 times what would give me something with this in the denominator? Well, obviously it's going to be A squared plus B, A squared plus B. Okay, so what does that give me in the bottom? Gives me that. In the top, that's A, if we were to look at it visually, see this like with parentheses, that's A times quantity, a squared plus b, that gives me a cubed plus ab. Okay. All right, so what have we got so far? So we took a over 1, put that a over 1 there. All right, and we had to change this a over here into a fraction that had a squared plus b as a denominator. Okay, and so we did that. And what did we end up getting? We got a cubed plus b over a squared plus b. Okay, any questions? All right, so basically this a over 1 just became this. All right, so now we have a cubed plus ab over a squared plus b minus a cubed over a squared plus b. Okay, now remember, now that we have a common denominator, we can take everything and we can take both numerators and put it over that common denominator. So we get a squared plus b in the denominator. Okay, now remember that subtraction sign, it just simply causes this positive a cubed become a negative a cubed. So we got a cubed plus ab minus a cubed. Okay, now what happens to our a cubes here? Yep, they cancel out. So what happens then when I take a minus a cubed over a squared plus b? What do I get? I get ab over a squared plus b. Now, check it out. Remember how much you guys like to cancel, right? Cancellation. Remember how fun that is? Look what we get to do. We get to, since we have the same exact quantities here, 1, 1, 1, 1, my answer is 1. Okay, so only do numbers 1 through 11. And we will talk on Wednesday. Okay, enjoy.